Hello, everyone, and welcome to the Information Playground. I'm Ron Bush and your host. I own Ron Bush Consulting Incorporated, and we are a cybersecurity company or consultancy. If you own a business and you are concerned about your safety in the cyber world, give us a call, send us an email. You can find us at ronbushconsulting.com. We're coming to you in a variety of ways. First off, I always like to feature WVLP. WVLP FM is a local radio station in Valparaiso, Indiana. They're 103.1 on the FM dial, but if you'd like to stream us from there, please go to WVLP.org. They're a great community radio station. They do a lot in the community, and I'd love it if you took a look at their website. You can stream us from there, of course, but you can also find out how to get involved. You can also, oh, by the way, on WVLP, the Information Playground is broadcast Monday mornings at 8 a.m. and Friday afternoons at 1 p.m. You can also find us on any of the podcast channels under the Information Playground and also YouTube under the Information Playground. With that, I've got two great guests with me this morning, Matthew Cloud and Phil Moorhead. Both are with Ivy Tech. Matthew, would you tell folks a little bit about yourself? And then in turn, Phil, if you would, do the same.
Sure. Thanks, Ron. Thanks for inviting me back again today. I appreciate the opportunity to chat with you here. I am the department chair for the School of IT at the Lake County campus. That's in Gary, Indiana, East Chicago, as well as Crown Point, Indiana. So it's all that northwest, extreme northwest part of Indiana. And that's over 8 different IT programs in the school.
Great, great. And Phil?
Hey, I'm Phil Moorhead. I'm currently retired, sort of, from Ivy Tech. I worked there about 20 years after I worked in industry in IT and electrical engineering, electronic engineering. I was a chemical engineer in my real early days. I currently teach mostly security, networking, anything that the campus wants me to teach out of Lake County. I do it remotely because I live just north of Indianapolis, and it works out very well. And I have my own little consulting business for security. So we're not in competition, I should tell you that.
That's fine. We wouldn't be in competition anyway. I think friends get along. Maybe they help each other, but they don't compete against each other. So that's all good. So what we're going to talk about today, the program is really going to start with 5th generation programming languages. It's an area that is probably going to get technical from time to time, but I've asked my co-panelist here to be sure and explain acronyms, and if we get too deep in the weeds, we'll try to come back a little bit and make it speak in English again. We'll be getting into artificial intelligence and all that area takes us, simply because that's where we're at, and that's certainly where we're going deeper for the foreseeable future. So 5th generation programming languages, let's start there. We had to get to 5 somehow. What are we back? Let's go back to 1, 2, 3, and 4. And
sure, we've talked about 5G on wireless and networking and those kind of things. What does 5G mean? Well, there's a 5th generation for programming languages, which is actually not that new. It came out originally in the 80s, but it didn't fare well, right? So it kind of disappeared again, and then it's been coming back in a different way. And so I'm kind of co-opting that term, and others have as well. So there's not consensus necessarily yet. It's not like a law of physics or something, but 5th generation language is basically the attempt to democratize programming. In other words, making it so that anybody could get involved and write a program, but you don't actually have to know a programming language, right? You focus on the logic.
Excellent. Let's talk a little bit about what you just said. 1st generation, which, by the way, they weren't called generation languages until the 3rd generation. So 1st generation is pretty much machine language, bits and bytes, zeros and ones, however you want to term it. Then you've got assembly that comes along really as the second generation language. The third generation, I'm not sure where RPG, I mean, I wrote an RPG back in the 80s, which was an IBM language that was actually discovered in 1959 or created in 1959.
By the way, I should point out RPG, for those that think in modern terms, role-playing games, no, it means report program generator.
Excellent.
And I wrote in that and COBOL. It was really a third generation, sort of, but it was designed to take away the machine language information. And so in all of those languages, and even up into fourth generation, we'll get to that later, my rule of thumb as a programmer was all of my programmers could write 8 lines of good code per day. Students look at that today and say, you got to be kidding. I can write 8 lines in a couple of minutes. Yeah, but is it fully debugged? And that's the rule that we used. And it was a pretty good rule. I think it applies in even 5th generation. Now, Matthew may have some other information on that, but if you just write code, there's no guarantee that the code is going to work. It could blow the program up or stop it. And most of your listeners probably have had that happen when they get a program that they start and all of a sudden it says, I have to reboot. Well, that's the problem. So 8 lines of code per day.
And Phil, that's a good point, that especially with this being a program focused on security, often when people start writing code, if you will, or they're smashing code, what they're really doing is trying to figure out a way just to write it and automatically somehow it's going to work the way I'm typing it out. And where you should start if you're writing code, once you've got the logic figured out, that's the first thing really you should do. Flow charts and those kind of things, modeling languages, how do you actually intend for it to work? But once you start actually implementing the code, the first place I always started with my software company was writing the error code, right? How do I handle errors? There are some things that are handled gracefully by the operating system or by a programming language, but often anybody who was using computers in the 90s in particular, we're very familiar with something called a general protection fault, right? And then it might give you this hexadecimal code that gave you something, and sometimes it gave you nothing. And that's not really very helpful. But usually that was done because whoever wrote that program did not write proper error handling. And when you don't write proper error handling, that means people can insert code or modify how they're doing things in a way that wasn't intended to get access. When I took programming when I was in high school, they actually had programming then. That the systems we were using BASIC, I think is what they were teaching us on. And my friend next to me, he's sitting there and he held down the control key and he typed in his first name and it gave him access to all the records for the school system. Now he was just playing around with it, but it was the control escape system, and there's something in there was giving him the escape to get right into the system. He wasn't trying to do it. He's like, what did I just do? Right?
And
but that's important. And as these languages get more complicated and your work becomes more complex, it can lead you into this nightmare of spaghetti code, which was early on. The earlier languages were difficult for that. But I was talking with students on Wednesday, teaching a class on computer science applications to non-computer science students. So I started talking about first generation code of just turning the switches off and on. And I go to turn the switch off and on in the classroom and it starts frizzing. I'm like, well, you know what? There's probably a bug in there. Literally a bug, right? And that's where that comes from. They don't realize that bugs in computing languages, when they talk about it, came from actual bugs. And Phil, you've probably had more experience with that than I have.
Yeah, we had all kinds of bugs because when we worked on the robots, this was out in a relatively dirty factory area. And so you could have machine parts, you could have metal dust get between the contacts, you could have it short out transistors or the circuits, and it would give you strange things.
I think the I think the original name for that, if I remember the story correctly, might go back to ENIAC. It was one of the early computers, and it was a lady whose name escapes me that discovered, I think it was a moth in one of the
Right.
computers that was causing a problem, and there's a bug in the computer, and it stuck. Let's move forward a little bit. Both of you, I think, have touched on it security-wise. As a matter of fact, I just read something not long ago. Some application, some new release was allowing people, Matthew, just what you said, to allow people into the system just by signing into it. And I wish I'd realized we were going to go here today, because I just read it the other day. Getting into the program.
In the early days,
It
we
was,
wrote code quite.
excuse me, Phil, it was dealing with Experian. Going into Experian to pull a credit report, if you put in all zeros for your date of birth, you could pull anybody's. So I could pull your credit report. I could pull everybody's credit report. All I had to do was put in the name and put in some other qualifying thing and put zeros in for the date of birth. Hopefully they've fixed that now, but I just read that the other day. We're still there. We're still dealing with stuff like that when we talk about security. So I'm sorry, Phil, I wanted to finish the
Okay, yeah, that's good information for your listeners. In the early days of programming, because it was sometimes difficult to get control back once an error had occurred, many programmers, and I did it too, would put a trap value. And a trap is basically, you want to enter, let's say, your first name. But we would set up that the computer would be watching, that if I put in a certain set of code, usually hold down control and hit something, then it would release from the program it was supposed to do and run some special code for you, so you as the programmer could check, well, what's it doing? If people happen to run across that, they could get in and do what we were trying to do as programmers, understand what the program was doing. A lot of that has stopped lately because there's better tools available, but some of the older programmers and some of the older programs still have that buried in it. I teach a Java class right now, and one of the things we had a discussion about a couple sessions ago was, let's enter a zip code, and this goes to security. Students said, okay, we'll look for 5 numbers. And I said, well, what if I enter an E? What if I enter an A? What's going to happen? Well, you won't do that. And I said, yeah, right. And so we talked about how to trap, how to catch. What are the errors that you need to know can happen at this point? And as Matthew said, let's program that first. Let's understand what could potentially go wrong and then work around it. And what are you left with? Only the good stuff. Now, there comes a point when you can't make a determination what's an error and what's not. A good example, we want you to enter your age. Okay, what kinds of problems can you have? And so this is the way I teach programming. How do you think through a problem? You enter your age. What if you put in an I? Well, that's obviously wrong. What if you put in -5? That's obviously wrong. What if you put in 48? Is that wrong or not? For you, it might be. For me, it's no way. What if you put in 200? They're probably wrong for a person's age. So now we have to take a true error, like enter a negative number for an age, and look at what you're entering as not an error, but another version of an error. It's not a true error, but it's not the right value. And how do you handle those? How do you look for them? How do you mitigate it? How do you decide Yes, the user is 48. A couple ways to do that. This gets back to security again.
And it's really philosophy. I was talking with a company called New Apprenticeship, newapprenticeship.com, that's working on apprenticeships with Infosys and some other groups on how do we tie these into building areas of IT, help desk, IT security, these things out there. One of the comments that was made is there's a lot of people actually that are teaching in computer science that have theology degrees. Right. So I've hired a few myself. But it's interesting to note, and that's kind of why I wanted to have this discussion. As the languages that we've had, what Phil has been talking about here is really the philosophy. He's not talking about how to do it in a programming languages. It's just, what do we want to say? What's acceptable? What's not? Typically, though, when we focus on what the majority of people program in, which is the third level, third generation programming language, like Java or C++ or Python, they're focused on the syntax. Python, not so much, right? Python's a little easier. I almost put that into a fourth generation for me. It's very different from other third generation languages in the fact that you don't have to think about the physical level, right? You're not thinking about how many bytes does this take? How many zeros and ones do I need to handle when I'm telling you I want to assign there's 12 apples in my basket. I don't have to tell it that the basket is storing an integer value, right? And that might stop somebody right there. What is an integer? Right. And so integer is one of those ways that we tell it we're going to store so many bits of information on that computer in the physical RAM as well as the physical hard drive. We're storing it for long term, right? Somehow we have to tell the computer how much memory do we need to reserve. And so those first generation languages, we're doing all that with switches, right? Off and on. And there were some other methods. But that machine language ultimately is talking either is it off or on. Until we get to quantum computing allows us to be off and on at the same time, or maybe somewhere in between. That's a whole other subject for another time, but that's not the way we program or our computers work today.
And if users, if listeners here are using computers and they want to learn more about that, if they look up fuzzy logic, you'll get a real good handle on quantum. The basis of quantum.
Fuzzy logic or Schrodinger's cat, rather.
Yeah.
So
we've kind of talked around the second degree there because it's harder to define, and because third generation languages are written more like humans talk, right? It's not exactly the same, but it's human readable. You can read zeros and ones in machine language, but it's really hard to program. And how many zeros and ones? That's like the movie The Matrix, where all they see are zeros and ones. That's what you're really doing there. That's difficult to decipher. And so the second, our second generation of languages like assembler allowed us to use 3 bits of code, right? To say, we're going to move this, we're going to store it in a block, we're going to move it from one registry of memory to another, saying it's moving from this part of our memory to another one. But it becomes difficult to follow the sequence of what's happening, and you have to have a set of numbers to keep track of where you are in the code and say, I want to go from this line of code to the next line of code. That's okay until you decide, well, maybe I really need to add this into the code. Now I got to change everything and change what go-to number I need to go to. So it becomes very difficult to manipulate as to what you're doing.
Yeah, one of the first places I worked in, RPG2 is obviously what they wrote in. We made jokes about assembler programmers. It was kind of like the guys with the slide rules in their pockets, you know. They were. Anyway, let's move on to fourth generation languages and get to our fifth, and let's get into what we're here for. I will say, just as an aside, I didn't realize that about hiring people with theological degrees. It takes me back, you know, to ancient times where the education for an attorney, a lawyer, if you will, and a priest were pretty much the same. Wasn't that much difference in the early church. Here we are, the education for a priest or a pastor not all that different, at least in the critical thinking and logic part of things, for a programmer. I had no idea. Excellent. So fourth generation languages, what do we do with those things?
So like report generation, normally we think of fourth generation languages, and there is some dispute on what they are, but they're more specific languages. They could be termed like a third generation language, but they're not used for everything. So like in C++, Java, Python, those languages, C#, Visual Basic at one time, were all languages, even COBOL, that you could write it and compile it. You can make it work for a certain machine, right? So for a certain processor, a certain operating system, and you'd have to compile it for each one of those so that it could work on different machines, right? So it works out there, and but you could do that for any of them. You have to have a compiler that will allow it to run on there, that translate that all back down to the machine language for you. That's doing all that for you, right? But you could use it potentially on anything from a Raspberry Pi to your cell phone, right? Those are very broad, but fourth generation languages are more specific in some ways. HTML and JavaScript are very specific languages that they're used for web browsing, right? You've got your design behind it, and you've got JavaScript to allow you to manipulate it and make it more dynamic. HTML is telling you how your web page is going to be delivered. But there's some difference between how that works on even different browsers on the same computer. It can look differently because it's being interpreted on the fly. It's never being compiled and written to a machine code when you send it to someone. If you could write a web page, a lot of people are familiar with writing a simple web page. But because it's interpreted by that browser and by that computer, it could look different potentially on every computer that you go to. As we've moved to HTML5 and CSS3, that's become less of a difference, but there's no guarantee that all those fonts or whatever you might be using is going to be there, right? So those are more specific. MATLAB could be within that group, matrice-based for engineering. Anything that you might use for like crystal reports was used in accounting quite a bit, to go off of Mass 500 or Mass 90 or what's it called? QuickBooks, right? So you could create your own reports out of that. So you might have a report generator where you're writing a form of code. You might not always be using code, but they actually had coding in there. That's where in my consulting company, when the accountants got stuck, they're like, I need this report and I can't quite make it work the way I want. They have me come in and actually write the code behind the crystal reporting mechanism so that they could get whatever they needed for their final reports, right? Sometimes I got a little tricky because it would get really technical. So it's still not breaking loose of knowing these sometimes archaic syntax. And I love Python, but it's written after MontyPython and has that feel, right? It's you have to have that kind of mind think to understand what's going on there.
I think the word you're looking for is quirky.
Quirky, yes, thank you. So that brings us to really the fifth generation languages, where we're focused more on how to think about the logic. And you don't have to care about the syntax. You don't have to care about how many bytes or bits that you're storing or what those zeros and ones are. You can if you want, but there's no requirement to. Now, that doesn't mean it will do everything. You might have to still go back and trick the language out a little bit. But for most people, you can get in there and build something that will actually work for you without knowing how to code at all.
Fascinating. So, how does it, you know what, we're at a good pause. I'm going to take a pause, identify everything, and then remind folks who they're listening to. I'll be asking you gentlemen how folks can reach you if they have questions or want to pursue a conversation with you. But first, let me identify WVLP. It's a great radio station and one that we broadcast from on Monday mornings at 8 a.m., Friday afternoons at 1 p.m. They're in Valparaiso, Indiana, and that's always going to be Central Time. So if you're interested in becoming part of the community or getting involved in the community, WVLP is a great place to start and a great place to get involved. I've been with them for years. WVLP.org. Check out their website. You can find the information playground there, or you can find us on any podcast platform, Spotify, Apple, Google Podcast, any of those. Look us up, the Information Playground. You can get us on demand that way, or watch us on YouTube under the Information Playground. I'm Ron Bush. You can reach me if you have questions about the program or about content. Ron@ronbushconsulting.com. Matthew, if folks have any questions, how can they get a hold of you, and Phil likewise?
So the easiest way to reach me right now is my email at mcloud3, that's MCLOUD3, cloud like a cloud in the sky, or cloud computing, at ivytech.edu. Our phone number is 219-981-1111, lots of ones, right? Extension 5369.
Great. And Phil?
You can reach me at my Ivy Tech email address. That's probably the easiest. PMOORHEA, there's no D on it, at ivytech.edu. People ask why 8 characters. Well, when I came into the system, our email was limited to 8 characters. So that tells you how long I've been around. If you don't want to use that one, you can always contact Ron. He can get a hold of me. Since we work together, we know each other's email addresses, obviously.
Excellent. Thank you. So let's move in now to application, 5th generation languages. Where do we go with this? Now that we understand how we got here, where are we at and where are we going?
So there's a lot of different areas that we're applying 5th generation languages today that most people haven't even realized they're doing it. Particularly even within teaching computer science. We get so much into the work that we forget to look at the trees in the forest, right? So one of the tools that we've used at Ivy Tech, there's 2 that we use, Flowgorithm and Raptor. So Flowgorithm is a tool that works at a very simple level, written by another community college professor, that's freely available, GIRITHM, I believe, like flow chart and algorithm put together. And you create the flow chart, and your input and your output is like you're texting somebody. So most people are familiar with that. It's not just for the teenagers. I know my father texts me frequently. So he swore he never would, but hey, even that generation's bought into it. So it's very simple to use, and it will write the code for you in 30 different languages. Very simple. You just go through, here's where we're starting, here's where we're ending, and then we start adding the little steps in between just by dragging and dropping or clicking on it to add. I want to store apples. I want to say if I have more than 12 apples, you get a basket. If not, we go the other direction. So you can think through the philosophy and the logic of what you want to do, not did I put a semicolon somewhere in the right place, right? Which is what you have with a lot of 3rd generation languages. There's a lot of ways you have to define the scope, right? And so often when you're focusing on writing good code, you're trying to eliminate your errors of you typing. And most people don't take typing anymore. It's kind of interesting to think about. The earlier programmers were called coders, or computers were actually women. Yeah. Right? For a lot of good reasons. One, we had people in the stenography pool that knew how to type. And so as keyboards became of use, women knew that more than men. Most men did not know how to do that. When I took typing in high school, I took it, well, I was the only guy in the class, but I also wanted to know how to type. I wanted to do more with programming. I thought the odds were good in both cases. So, and we shifted over time, and there's been this misconception that happened more like the 80s to 90s of this white male who's a loner and doesn't talk with other people as being the typical, or the person that you really want to have as your programmer. I don't really know how or why. I've read a couple books. I don't know that I agree with them on how or why that happened, but it just isn't true, right? The best programmers are not those that go sit in a room by themselves and don't associate with other people. They may be able to write some good code. That doesn't mean there aren't people who couldn't do that. I have some autistic students who don't necessarily communicate well with others, but are excellent in cybersecurity, but they still have to learn how to communicate with others. That's the most important skill, because ultimately someone wants to use your product, or you don't have a product to sell and you make no money and you live in the basement, and maybe that's where that comes from. I don't know, but when we think about,
go ahead, Matthew.
I was gonna say, when we think about 5th generation languages, well, now you don't have to worry about all those little bugs of things of what's going on, and we can think about, how does this apply to other areas? Does it apply to theology or to business or to wherever, right? There was COBOL. You mentioned COBOL was written for business, right? I'm no expert on that, but my mother went through college the same time I did, and she focused on COBOL while I focused on Fortran. Neither one of those languages really exist anymore, except for trying to fix what's out there.
Yeah.
Right.
And that's where you can get paid some pretty decent money, because companies have a choice. They can either get their programs recoded, or they can hire somebody to replace their aging programmer population who are not retiring, to keep their old programs alive.
Right. And so when we get to the 5th generation, it's allowing us to look at different aspects to make that code work for us. So one of those areas is artificial intelligence. I've worked in that area on machine learning for the last 20 years in different areas, starting with radiation protection to functional brain imaging, and what we're doing now more is in cybersecurity. But it's large amounts of data, and it's hard to understand when you've got a gigabyte of data coming at you. How do you make sense of it, right? How do you find those patterns? And there's a lot of statistics involved, a lot of high-level math that, frankly, it took me, we had 5 years of patient data. It took me another 5 years to determine how to make sense of it. And when I was done, they could use it moving forward, and you could tell in 6 seconds what to happen, right? But we had to find models that would work. And so when you look at data, you apply different models to see, will this work for this given situation? Up until recently, up until about a year ago, you really had to know, have 3 different master's degrees to make that work. Because that's the only place where this type of coding and the philosophy that you needed to know to make all that work. Now we've seen courses coming out. Intel started out with Maricopa County College, near to where you're living now, Ron. They started last year with an AI degree. We're working on adding that here at Ivy Tech through our NSA grant. We're going to look to see what we can add from that curricula. But I started a year ago using Oracle's digital assistant. So the Oracle's digital assistant allows us to, I had people that were professors in theater that went through it out of LA. When I was teaching this AI course last year, I taught a week of it. And within 3 hours, they were creating an AI chat bot to order pizza, right? It understood the intents of somebody making an order, having a complaint, or they want to cancel a pizza, and it would act upon that. But they never wrote any code. What is a pizza? What are the possible attributes of a pizza, like pepperoni or black olives or anchovies or whatever it might be? What's the size of a pizza? And then it tied in, they chose which model they wanted to use. Like, there's different natural language processing models that will do all that machine learning code for you to analyze when somebody types something out, is this what we think it's supposed to be, right? So it interprets that for you. And when it's done, it'll say, oh, I think it's 90%, it's a complaint, 10% it's canceling, maybe it's a 50%. These don't add up to 100%, right? These are all independent percentages that say it's different things. And so it will go with the largest percentage, but as you're training the model to say, this is what I want it to do or not, you can give it feedback. So, nope, you weren't right. And so it learns from that and says, okay, next time when somebody uses this sequence of wording, I want to respond differently, right? So it's just like training your child or training in a class, say, oh, nope, that's not correct. You got to go back and do it 10 times till it's right. If you give 10 bad inputs, now you're going to have to put 20, 30, 40 inputs that are correct to make that work properly.
Which is not that different from how people memorize, rote memorization. from how you teach certain behaviors. I mean, really the same.
Exactly the same. And it's a really simple tool. There are some difficulties getting out there because they give you $300 to use for free, but we're still trying to figure out how do we teach that, in more than one course. So I used up my $300 of credit. I stretched it out actually over 2 courses, but and I can use it for research, but there's still some difficulties with cloud-based technology making that work in an academic setting. But for production settings, for business settings, it's beautiful, right? And then we have another tool that we're using from Oracle called Apex, or Application Express. It's been out there for over 20 years. Joel Coleman over there is now a VP with Oracle over their software development, but he helped create that Apex and make it available for free and the Oracle Academy. And Denise Hobbs runs that for North America. If there are academics listening to this and want to connect to her, happy to connect you with her to make it available. But Application Express is a low-code, no-code system. It's a database system. And I put it in that 5th generation language as well. Now it allows you to go back and do 4th and 3rd generation languages. Like another 4th generation language out there is called SQL. So we've got that query language that's out there. When we have structured data that looks like a spreadsheet, if you use Excel spreadsheets, and we have columns that are there, if you're using an Excel spreadsheet, you can use different types of data as you go down. So I might use, for the first few rows, it's money values. I want to keep track of the daily sales. Then I put below that, I start typing whatever I want, maybe somebody's address. If I put that into a structured data system, it will reject one or the other because you can only have one type of data. I can't have a string type of data like an address versus a floating number like money, right? Because you have just numbers, no characters that you're storing. And so when you move to that language, it can be difficult. But what they've done is they've created this tool that you use online, and you can take an Excel spreadsheet, and as long as it's the same data type, it will import it in, and you can create a full online secured website database system, right, within a few minutes, right? Now, you have to know what you're doing and understand that you want reports and forms and that kind of stuff, but that's focusing on the philosophy of what you want to actually have there, not the mechanics of how do you program a form to come up or a report or anything like that. And so it's been a fantastic tool for us just teaching these concepts, which was so hard to teach until about 4 years ago when we did that. And now it's become a very popular course for us, our DBMS 110, the Introduction to Database Systems. Now, this next fall will be called Introduction to Data Analytics, because now we can really focus more on, again, the philosophy. What do we really want from that data? How do we make a report to the CEO or to the board? Those kind of things.
Excellent. So let me just mention, I think a lot of people listening to this are probably going to be surprised that artificial intelligence has been around that long. Some of the tools you mentioned, the one in particular, I think it was Apex from Oracle, 20 years. But let's take a look at, so where we're at. I think most people will be surprised artificial intelligence is employed in so much of what we see every single day, whether it's the New York Times, whether it's Microsoft having it write text for it, whether it's every support, tech support chat box, they're all artificial intelligence. Where are we going from this? Where are we taking it?
So like when you log into a system, often you'll have a reCAPTCHA there, and it'll give you an image and you say how many fire hydrants are there or stop signs or whatever it might be. And those are images that we're using to guide and create these systems like what Tesla is doing and others for automated driving systems, right? We're giving input into that. So please don't give it bad input.
Yeah.
Might save your life one day, right? And so as we build those systems, the good thing about that, it helps to eliminate bias in data, because it's anybody and everybody across the US that has access to the internet that would likely be using this work. It's not just a bunch of white kids sitting in a basement, right? If you will, right? And everybody has a bias. Bias can be a good thing, like don't touch the hot stove, those kind of things, right? But when bias causes harm or could cause harm, that's what we want to make sure we're not doing. And that can come from automated driving or determining if a tissue is cancerous or not. I did functional brain imaging for the most part, but the other half of the lab that I was in worked on prostate cancer and breast cancer, determining is that tissue cancerous or not by automatic detection. It's difficult for physicians to do that now because they have to take samples. It goes off to someone else who later looks at it because there's a huge backlog. There's not many people who understand how to look at the differences. And so as they start to teach these systems and say, no, that's good, that's not good, simple categorization. And you can go to code.org/oceans and learn about AI there and simple categorization and bias. It's written for kids 8 to 80, I like to say. A lot of fun. And like what should be in the ocean, what should not be in the ocean, those kind of things. And then as it gets trained, as you're training it through reCAPTCHA and other things, that's feeding data back into these systems that are all out there on the cloud, whether it's Oracle or Microsoft or whoever is containing those systems, to feed back to provide you better support, particularly in areas like healthcare. I want to know when I go to retire one day, maybe, that there will be these AI robots out there that can help me with my healthcare because there won't be enough physicians, right? We're already struggling on having enough physicians. We talk about insurance being the problem. Insurance is really not the problem. The real problem and why insurance and costs go up is there are not enough people to do it. And it takes way too long to get people through that process to do these areas that we have available to us.
Well, a study a few years ago had AI reading X-rays much more accurately than X-ray technicians were.
Right. Well, and we got to a point about 15 years ago. So I looked at becoming a radiologist in the early 90s. That was one of the fields I was looking at joining. And I noticed that the radiologist I was going around with at the hospital in Fort Worth, he had cancer in his muscles from holding up his patients. And so there were fewer people going into radiology in the US. And by the early 2000s, we were sending most of our x-rays over to India to be read. So you'd wait to get a response back because we didn't have enough people here in the US anymore.
Wow. And
so sometimes things would happen, like I have a son with Down syndrome who had many surgeries in his first year of life. He had heart surgery and other things that went on, but he kept turning blue, and he'd had in his first year of life close to 100 x-rays. The technicians called him glowworm. They saw him so much because we were trying to figure out why is he turning blue. Well, it turned out that he had what's called a Morgagni double hernia. So his diaphragm was not attached to his abdomen on either side. So his organs from below were coming up to his to his lungs, and he wasn't able to breathe. Well, that last page that was coming from India was not being transmitted back to the nurse. It was in all those reports. And when I look at the x-ray myself, that's when I went back in and got my master's. It was like, oh my gosh. It was reported this should have been taken care of 6 months ago, but nobody knew because the data wasn't being transmitted.
Wow.
And so those are the things that we can work on to keep it local. It reduces those kind of errors. There's going to be human error no matter what we do, right? In that case, it was just one person not feeding it into a fax machine. So all this technology is being used, but you're still relying on a fax machine.
Right, right.
So AI, again, allows us to look at it quickly and take those thought processes from not just one person, but from many radiologists. We're combining all of their yes, no's, this is right, wrong, that kind of thing, to build it in so that the science and art of being a physician becomes more practical. And they can have technicians do the work. You don't have to have somebody with 12 years of experience past their medical degree to be able to decide, is this something accurate or not? So
let's take that and talk a little bit about careers. What's available to people today? And age isn't a factor. Ivy Tech is a great example of that. You mentioned kids 8 to 80. I mean, you can be in high school and you can be 80. I think the oldest student at Ivy Tech is 80 something. So you can, it doesn't matter where you're at there. what can people do with learning about artificial intelligence, what's available to them at Ivy Tech, and what languages should they be, or what disciplines? I'll let you tackle the right term for that. Where should they be starting and wanting to end up, knowing that that's a movable destination?
Well, so all of our classes start out the same so students can learn more about it, and you'll use that 5th generation tool of either Raptor or Flowgorithm in our software development 120, our computing logic course, which focuses again on the philosophy of the logic of how a computer works. Mm-hmm. And so you get a taste of that there. And if you decide that's the area that you want to focus on, more on the philosophy and maybe some of the technical programming, we have a software development degree and certificates that people can move through. And we have a new course actually getting into secure coding and cryptography called SDEV 245 that is based upon what I'm doing some work on for a National Security Agency grant. And so we're building some new courses out through that. So there's a traditional pathway you can go through on that. And there's also a data analytics side of that. It's called database management currently, but at some point it will officially be renamed here. We decided as a committee a year ago, but it takes a while to get it all out there. It's a large college, but it'll be called data analytics. And that will go deeper into the analysis side, not necessarily the development side, but the analysis side. So there's these two different tracks, but you take the same first few courses and that'll help you decide where you want to go. If you're coming in from, maybe having some prior experience, maybe you're in your 20s, 30s, 40s, or 70s, wherever it might be, we have this cwct.us. So this cybersecurity workforce certificate training program is sponsored by a grant from the National Security Agency through Purdue Northwest, Ivy, the University of Tennessee, Chattanooga, and the University of North Carolina, Charlotte are all partners in this grant that are creating these new courses so that more people can get into the fields. Like AI, there's about 45,000 open jobs posted right now for AI. The National Science Foundation is projecting that 75 million jobs will be replaced by 123 million AI enhanced jobs by 2025, 4 years from now. That number I just said of 45,000 a day, that number has been doubling each month.
Wow.
It is growing at a fantastic rate. There's not a whole lot to find now, but by the time you get done with even a certificate, there will be plenty of jobs to go into. And even if it doesn't have a job defined, if you have AI skills that allow you to automate what you're doing, that's useful for any position. And that's why it will end up replacing. As people catch on, you're going to be in a higher paid job because you've taken on this work early. So we have a series of a track of 3 courses that you take in a row, actually 2 courses at a time, but 3 8-week sessions on AI and IoT security, so that you can do that through there. And it could transfer not just to Ivy Tech, but Purdue Northwest, the University of Tennessee, University of North Carolina, and we're looking for additional partners to join with us.
Excellent, excellent.
From a different perspective,
yes, sir.
When I'm hiring people, especially programmers, I don't look for a programmer. I look for somebody who knows how to think through a problem. We can always teach them programming, no matter what it is. Our classes tell us that. But I can't teach you how to think. And if you can't think, I don't think you can program.
Well said. The times that we used to do, I think back to the 1700s, 1800s, and even prior to that, a lot of education focused on logical thinking. One of the guys that wrote a ton of hymns, Isaac Watts, wrote a couple of books on logic, critical thinking. There's all kinds of excellent things written in the past. Critical thinking gets a little bit of press when you look at homeschooling nowadays, but I still don't see it offered in public schools. And I'm talking about K-12. One of the things that I do in classes is I talk to students, and I'm sure all 3 of us can say if we're looking at software development classes, we're going to deal with critical thinking, logical thinking. You have to be, at least in the older languages. Now, I haven't gotten into the 5th generation, so.
Even in AI and the 5th and eventually the 6th generation, critical thinking is still very, very important, because if you go down the wrong path, you're going to produce a report that either is wrong,
Mhm.
leads you the wrong direction, or just plain doesn't help.
Yeah.
Yeah. So yeah, when I was in school, they told us to create flow charts, and that doesn't mean that people actually did it. But if you didn't think through logically how this is supposed to work,
Mhm.
then you're going to spend a lot more time trying to figure out how to code. That's what's made me a better programmer, is I took the extra time to think through what I needed to do, and then I only write a few lines of code.
I think that
It's
helps you
so
in all
much easier,
life,
right?
not just writing code, honestly.
Yeah, it would drive some people nuts. So people that are not programmers, when I did that for like in biomedical engineering, the person I was working for, she sees me sitting at the desk and I'm just sitting there and I'm staring off into space. I'm thinking through the problem. It's like, what am I paying you for? You're paying me to think. That's what you're paying me to do. It's like, I can sit here and type if you want, but I can tell you how many companies I went to where they paid people by the line.
Yeah.
And there might be 2 million lines of code, but it only took maybe 1,000 lines of code to really do what they needed.
Right.
And then I'd sit there and look pretty for them, as pretty as I can.
Yeah. Well, we all have our limitations. What can I say?
But this is the area where I was talking with the dean at another campus this morning, and about AI. She's like, "Oh, I don't want to hear about programming." I was like, "Well, that's the point. You don't have to hear about programming." I said, "What if you could tell the computer to do what you want to do, and you don't have to write a line of code?" She's like, "Oh, that would be great." Right. So I think the biggest frustration I've had is from those that are traditional programmers. Like, "Oh, I want to do all the Python stuff. We're going to write all that." I was like, "Well, fine. There's still a need for that. Somebody still needs to write the code that automates the stuff for other people." Yeah. It's not saying we're going to eliminate programming or people doing stuff in a third generation language. We've pretty well eliminated the need for second and first for the most part, but some people still need to do that. Mm-hmm. But it reduces the need on people having to write and know the syntax and logic and just focus on the theory. What do we really want to accomplish? Which allows you to accomplish much, much more.
And we see application of that in our daily lives. If you use one of these things, a smartphone, you're going to probably use Siri or forget Bixby. Is that the guy for the Android? And you're going to say directions to I don't know, Cracker Barrel or something, and they'll come back and they'll tell you how to get there. You may say call so and so, and it'll do that for you. That's the beginnings of it, and that's everybody can relate to that. Imagine where we've taken that into all, maybe not all facets of life, but many more facets of life. Imagine what people like you with the creativity and the knowledge now can do with that as you program devices that don't even exist. One of the problems education has had for a number of years is they're trying to train people for jobs that don't exist. It's a challenge, but it's also an opportunity, like every challenge. It's an opportunity to dream bigger and to go farther and faster.
That's very true. And in academics, it can take quite a bit of time to change the curricula, what we're going to teach, which courses, and even the course content. Ivy Tech being a statewide institution using the same content at every one of our 19 campuses in 400 locations, including high schools and all that. Mm-hmm. It's a slow process. It can take several years to actually create a legitimate change in what's happening. So one of the ways that we've been working on that, we can use special topics courses. Like I did a special topics course this past fall on Pythonator 3, Rise of the Machine Languages. And Phil, you were a student for me in that course, which I felt very blessed to have you as a student in there. But
I was one of the students who complained the most, I think.
Oh, no, you did fantastic. But you spoke up. And that's what I love about it. When having an instructor in a course is great because I don't have to worry about whether there's a problem or not. I will know. But the original intent of that course, about halfway through, I realized this should really be 3 courses, not just one. And that's what you do with a special topic, especially on this. How do we take bleeding edge technology and make it work? And then how does that work for an entire state, including in the high school? That it takes time to test and see what works. yet the industry is changing so quickly. And that's what I actually like about these 5th generation tools. It allows us to focus more on thinking about what should we be doing as opposed to what must we do now.
Excellent. We've got a little less than 5 minutes, gentlemen. I want both of you to have a turn. What should we have talked about? Again, we're limited on time. What last thoughts, points that you want to drive home?
Go ahead, Phil.
I think the majority of what I would tell people is follow your dream. If you think you want to program, try it out. You'll learn soon enough if it's not for you. But in the process, you will learn, oh, I like this other area better. Don't just sit back and say, well, eventually I'll think of something. Get out there and try it. I did. I went in several different areas. I liked them all, in fact, but some people don't.
Mhm.
And until you try it, you won't know.
I've always had that problem. I've tried all different areas and I've liked every one of them. I remember riding up an elevator with a guy that you'd probably know his name if I mentioned it on air. And we're riding up the elevator and I told him I was in a new area, completely different from the last one I'd been. And he says, can't you keep a job? Like, well, yeah, I could, but I mean, this is fascinating. I'm over here now. And so anyway.
And one thing that students have to realize, or people have to realize, in my day, you typically work for no more than 3 companies in your lifetime. The general rule now for people just coming out of high school, they'll work in 7 different areas, perhaps in the same company, but more likely a different company.
Yeah.
So don't limit yourself to what you're learning right now. Learn everything. Yeah. Because eventually it's going to come back and help you.
Yeah, those are great points. And having these skill sets will set you apart from your peers. Mm-hmm. When I took a course in photonics and we were imaging a nanoparticle in 100 different layers and then rebuilding that image, most of the students were doing that by hand. Yet, because I noticed there was a way I could actually code the system, by the time my colleagues that were working with me in the lab that were doing the physical images, I had it automatically rebuild the image. By the time they were done, it just hit one little thing in a few seconds, it was done. Whereas everybody else, it took them a good week to figure out how to put the images back together. Right. So those kind of things really help you. And if you can have a computer do things for you that you would automatically want to have done, whether it's turning off your lights and turning them back on in your house, those kind of things, greeting you when you come in, playing your favorite music, or, maybe you want to hear Valerie play or something or whatever, right? You've got those kind of things happening for you. It makes your life easier so that you have more time to do the things that you really want to do. And we can get into other areas more easily where this technology can help, like with Calumet College of St. Joseph and the program starting there, where it's a merger of cybersecurity and criminal justice. You can have a minor in either one and a major in the other one. And so that you can merge those together. And we're building a program as well on the AI side with Holy Cross College that will go to 4+1. So you can get your master's in a year at St. Mary's and continue for a doctorate at Notre Dame. So that allows us to get deeper into AI at an earlier stage, but you could apply it to biology, theology, law, wherever you might want to go with it. You're using these skill sets inside of those careers.
Great. What a great note to end on, gentlemen. Been a pleasure having you on the program today. You've been listening to the Information Playground. My guest, Phil Moorhead, Matthew Cloud. I'm Ron Bush. Thank you for being with us. I hope you enjoyed it. If you've got questions, I've got 10 seconds. Matthew, your email address, and Phil, yours, and I'm Ron at ronbushconsulting.com. Matthew?
Yes, mcloud3 at ivtech.edu.
Moorhead without the D at ivtech.edu.
Excellent. Well, thank you for being with us. Look for us under The Information Playground. Catch us on WVLP or any of the podcasts or YouTube channels. Thank you.